First, we need to design the female by selecting the wing size is vertical and the wing color, the body color is black, and then we need to select the mate for mating, and then design the male one, and then mate the flies, and then select the female and male, and again mate the flies. So this is the parents costume. And now look at the table, and we can see phenotypes, and now fill up the table. For the expectation number, we need to first find the ratio. So the null hypothesis is follow the ratio 9:3:3:1, and the alternative hypothesis is does not follow the ratio 9:3:3:1. So for the expectation number for the first phenotype, we need to times with 9/16 times with 1035. And for the second phenotype, we need to times 3/16 times 1035, and then the following phenotype also same 3 times 16 times 1035, and for the last phenotype is 1/16 times 1035. For the second, the chi-square table, we need to fill up the hypothesis first, 9:3:3:1. So, and then we get the hypothesis. So fill up the table. For the O minus E bracket square is we need to minus the observed with expected, and get the answer is need to square with square. So we need to square all the answers we get it. So for the following table, for the minus E square divide with expected, we need to divide the value we get on the third column with expected number, so and we get the answers. The degree of the freedom 4 minus 1, because we have 4 traits equals to 3, and for the total chi square we need to add all the answers we get it for the observed minus expected square divide with expected. So the conclusion is, since the value of the total chi square is 620.1 is higher than the value level of significance 0.00, the null hypothesis is rejected. Therefore, there is a significant association between the variable.
Assalamualaikum. My name is AFIQAH BINTI HISUMMUDDIN, and I am from DBT4B. So I'm going to show you a simulation of dihybrid cross between female fly with vestigial wings and black body color with wild type male fly. So first I will be heading to the simulation website. So this is the simulation website. So first for female, I will change the color to black, and the wing size will be vestigial. So for main fly is wild type. Wild type. Next we click mate flies. So as you can see, this is the cross between female and male fly. So at the bottom we can see the F1 offspring. So next we will going to mate between these two F1 offsprings. So this is the result for the F2 offsprings. So next we're going to analyze the data. First we have to ignore the sex of flies so that we can analyze the data between the traits. So there are 4 traits, which is wild type, vestigial wing, black body color, and vestigial wing with black body color. So next we're going to see the hypothesis. For dihybrid Mendelian cross, the ratio is 9 to 3 to 3 to 1. So next we're going to test the hypothesis. So this is the result. From this result, we can calculate our chi-square statistics, and we can also find our degree of freedom. And then we're going to make a hypothesis based on the result. Alright, since that we know the ratio is 9 to 3 to 3 to 1, the null hypothesis is to follow the ratio. And the alternative hypothesis does not follow the ratio. So for the expected number, we're going to calculate all the observed number, and the formula is 9 over 16 times 1000. The total is 998. So times 998. Right. So the answer should be 561.3. So the other calculations for vestigial wing will be 3 over 16 times 998. For black body color is the same, 3 over 16 times 998. But for vestigial wings and black body color will be 1 over 16 times 998. So for the expected number that I have calculated, this is the expected numbers. For degree of freedom, the formula is number of thread minus 1. So we have 4 types of thread. So 4 minus 1 is equal to 3. So the degree of freedom is 3. For the chi-square calculation, have to put all the observed and expected numbers into this formula, and next we're going to add all the numbers to get chi-square number. So for the total chi-square, we have to add all the numbers. So for our hypothesis, we're going to check the degree of freedom and our level of significance using this table. So our degree of freedom is 3 and significance level of 0.05 is here. So is 7.815. So since that our chi-square is 634.95, which is higher than 7.815, we are going to reject the null hypothesis, which is this cross does not follow the ratio of 9 to 3 to 3 to 1. So this is the hypothesis. Since that the calculated value is 634.95, which is more than 7.18815 at significance level of 0.05, the null hypothesis should be rejected. Therefore, there is a significant association between the variables.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is ASHRAF, and today I will explain about simulation of the hypercross of Drosophila. So first, I will design my female fly. So for the wing size, I will choose a vestigial, and then for the body color, I will choose a black color. Then select fly formatting. Next, I will design my male fly. So the trait of male fly is wet type. So select fly formatting, and then mate flies. So this is the result of F1 cross, which is female and male fly. So next, I will cross this fly and this fly. Just click this and this. So make flies, and then this is the result. This is the result for F2 cross. Okay, next I will go to analyze the result. So just click ignore sex of flies. And then, as we can see, they have 4 types of traits, which is wild type, vestigial ring size, black body color, and also vestigial and black body color. Okay, so next I will include the test of hypothesis. So for the hybrid cross, the ratio is 9:3:1. So 9:3:1. Next, click on test your hypothesis, and we will get the results. Okay, so next I will calculate the results.